The lesson topic for this video is solving radical equations with quadratics, and these are examples of level 2s. Okay, so the first example we have here, x equals the square root of 2 minus x. We are going to solve just like we have been doing with solving radical equations in the previous lessons. We're going to use the reverse of PEMDAS. We're going to undo those steps and including, again, exponents or radicals, right? So first we're going to add or subtract anything. Now remember, if it's already under the root, that's not a part of adding and subtracting. That is part of the radical, okay? So everything that's under there. So there's nothing to do here with adding and subtracting. So the next thing we're going to do is we're going to multiply or divide, and again, there's nothing out in front of the radical to divide by or multiply by. So the next step is we're going to use our exponent or radical situation. So we're going to undo this radical here by squaring this side of the equation, and that means we need to square this side of the equation as well. And now we will cancel this square here, square root with a square, and on the left hand side we're going to get x squared equals, and on the right hand side we have 2 minus x. Okay, so now what we have here is we have a quadratic situation. All right, we have an x squared term, which means we are going to need to solve this using any of the solving quadratic skills we've learned in previous chapters. Remember that in order to solve a quadratic, we want everything that has an x squared and an x term, that is. We need everything on the same side of the equation, and we need it to equal 0. So the first thing I'm going to do now is I'm going to subtract this 2 from both sides of the equation, and I'm also going to add this x to both sides of the equation. All right, there's the equal sign there. I'm doing the same thing to both sides so that I can get everything on one side. So now on the left-hand side, be very careful here. None of these terms can be combined. They are not like terms. So we have x squared, and I'm going to put this in order here. We have plus x, and we have a minus 2. And all of that equals, well, 2 minus 2 cancels at 0, and negative x plus x is also 0, so we have 0. So this quadratic equation can be solved by either factoring or by using the quadratic formula. And you can choose to use whichever of those methods you want, as long as it is factorable, then you can factor. And in this case, let's take a look to see if it is factorable. Remember, we're going to take that c value off to the side. That's this here. And we need to find out, by the way, let's back up 1 second. We can take that c value and write it here because our a value is 1. So it's the quicker form of factoring. Now we think of what are the factors of negative 2. Well, 1 times 2 is 2, but one of them needs to be negative, right? And now it turns out that these two do in fact add up to 1, which is the number here for b. So this is factorable. We can now put our 2 sets of parentheses down. And we know that the x times x will help us get, x times x gives us the x squared. And then we take these two terms here and we put them into our parentheses. So we have minus 1 and plus 2. Now in order to solve this, since we have two factors that are being multiplied and it equals 0, we can use the zero product property, which says that we can say that x minus 1 is 0 or x plus 2 equals 0. Now we'll solve those. In this case, x equals 1, and here x equals negative 2. Now just like with our solving radical equations with linear, not quadratics, our last couple lessons, we do need to check to see if these are extraneous solutions. So we need to make sure that both of them work in the original equation. Okay, so I do think I need a little bit more space here. So what I'm going to do is I'm going to kind of get rid of that over there. All right, so we're going to go ahead and check to see that both of these solutions either work or do not work in the original equation. So our original equation was x equals the square root of 2 minus x. So I'm going to start by putting 1 in for the x's here. So we have 1. Does this equal the square root of 2 minus, the x value here is 1. So does 1 equal the square root of 2 minus 1, which 2 minus 1 is 1. So does 1 equal the square root of 1, and the square root of 1 is 1. So this one checks out, and it is a solution. Now we need to check the other one. So our equation again, x equals the square root of 2 minus x. We're going to put negative 2 in. So negative 2 equals the square root of 2 minus negative 2. Again, notice we're putting in a negative 2 right here for x, so it's a negative negative. So we have negative 2, we're wondering if that's true. Is negative 2 equal to 2 minus negative 2, which is 4? Does negative 2 equal the square root of 4? And the square root of 4 is 2. And the answer is no, they are not equal. So negative 2 is an extraneous solution. Okay, so why don't you go ahead and give this one here a try, and then we're going to try something on the next slide that gets a little bit trickier. So go ahead, pause the video, try this one, and then we'll move on to the next one. Okay, and this is what you should have arrived at. The answers are 0 and 8, and they both do check out, and so we have 2 solutions to this equation. Okay, so now this example is going to be a little more complicated. Okay, we start the same way. Now, first of all, let's back up for just a second and think about this idea of PEMDAS again, or PERMDAS. Okay, well, how we're going to work backwards. Okay, so adding and subtracting would be the first thing that we would normally do, right? However, right now what we need to do is we need to make sure this square root is alone on one side and that we have everything else on the other side of the equation. And this is because in these examples versus the level 1 questions, we have 2 x's, one on each side of the equation here. So if you're thinking add or subtract, we want to add 5 to both sides. Okay, we're not going to do this, so you don't have to write it, just watch. If I add 5 here and then I add 5 here, what's going to happen is we're going to get this x plus 7 in the square root plus 5 equals x, and that's not going to help us at all because we still can't get those x's together. Okay, so we're not going to do that. Instead, what we do is we make sure that the square root is isolated, which means alone, and it is. And now we are going to continue with our radical. Okay, so we are going to square both sides to get rid of that square root. And when we square both sides, you guys, it is so important that we put parentheses around this x minus 5 over here. I had even done it on the previous examples. We have to for sure do it in this example. Because what's going to happen is the square root and the square are going to cancel, and we have x plus 7 equals x minus 5 squared. Now, it is so important that you remember, okay, that's how important it is. It gets an exclamation mark and a star. Do not tell me that x minus 5 squared is x squared minus 25. That is not true. What a lot of people want to do here is they want to square x and they want to square the 5, or some people even put this plus here, x squared plus 25. Okay, that's not true either. You can't just square x and square the 5. You need to square the binomial x minus 5, which means we need to do x minus 5 times x minus 5. That's what squaring a binomial looks like. Now, what do we have to do right here then? We need to FOIL. Hopefully that's what you were thinking. We need to multiply by using the FOIL method, the first terms, the outside terms, the inside terms, and the last terms. So on the left-hand side, I'm going to leave my x plus 7, and on the right-hand side, I'm going to FOIL. Multiply the first terms, x times x is x squared. Multiply the outside terms, which is x and negative 5, so negative 5x. Multiply the inside terms, which is negative 5 and x, so minus 5x. And then the last terms, right? And that's negative 5 times negative 5, which is positive 25. Now, we'll combine like terms, the negative 5x and the negative 5x. So I have x plus 7 equals x squared minus 10x plus 25. And now once again, we have a quadratic situation in which we have an x squared term and a couple x terms. So in order to solve this, we need to get everything on one side of the equation. We need it to equal 0, right? So I'm going to subtract this x from this side, and I'm going to subtract it over here. I'm going to put it by its like term. And I'm going to subtract the 7 from this side, and I'm going to put that by its like term as well. These are 0, so we get 0 equals x squared minus 11x plus 18. All right, so once again we have a quadratic situation, and the quickest way, in my opinion, to solve this is to check to see if it's factorable. So I'm going to take the c term, since the coefficient here is 1, and I'm going to list the factors of 18. 1 times 18, 2 times 9, 3 times 6. We do notice that 2 plus 9 is 11, and 11 is in fact the number we want here, but we want it to be negative, which tells us that both of these need to be negative, because a negative times a negative will give us that positive 18, and yet it'll add up to negative 11. So this is factorable, and we need to put our x's here, and our minus 2 and our minus 9 in, and we will now use the zero product property to solve. We get x equals 2, and we get x equals 9, and we cannot say that these are our final answers yet until we check them both in the original equation. So we'll go off to the side again here. I'm going to make myself some space. The square root of x plus 7 equals x minus 5 is our original equation. You do have to start with the absolute original equation. We're going to put 2 in, so 2 plus 7 in the square root, does that equal 2 minus 5? We have the square root of 9, does that equal negative 3? The square root of 9 is 3, does that equal negative 3? No, it does not. So positive 2 is not a solution. We'll check the other option. 9 plus 7 in our square root, does that equal 9 minus 5? This is the square root of 16. Does that equal 9 minus 5, which is 4? Square root of 16 is indeed 4, and 4 does equal 4, so yes, it checks out. So x equals 9 is our solution. All right, here's one last example. If you want to do this one, go ahead. If you don't, if you feel like that's enough for now and you want to practice in class, that's fine. Your choice at this point. See what you can do. I will put the solution or solutions at the end. So your answer is x equals negative 3, and if you want any help with that one, let me know in class.